Lura fl-studios ċandira diretta minn intervista għall-oħra, semmejtilkom aktar kmini, ser nitkellmu ma' xi ħadd li qiegħed jagħmel riċerka fih dan l-Università ta' Malta, d-Dipartiment ta' l-Engineering fil-fatt il-Faculty of Engineering, u ser nitkellmu dwar l-użu tal-enerġija fid-djar tagħna. Intervista interessanti se ssir bl-Ingliż minħabba l-mistident tagħna mhuwiex Malti. Good morning, Reiko Raute, yes?
Good morning, bonjour.
Bonjour. Did I pronounce it correctly?
Yes, very good.
So, Reiko's from the Faculty of Engineering.
Yes.
You're conducting a very interesting research at the moment related to appliances we have at home or anything using some sort of motor which uses energy. So, a couple of examples: washing machines, vacuum cleaners, air conditioners, etc. What is the problem of these appliances? I mean, they do their job quite well, but is it consumption? Is it when they start up?
Yes, the thing is we use many motors at home, and every household has about 10 to 20 motors. And all these motors get larger in size, bigger and bigger. We want to have strong water pumps, strong air conditioning systems. In Northern Europe, they use something like heat pumps, which are very big air conditioning systems to heat their homes. And the problem is when you start motors, they have a large inrush current. It means they take quite a bit of current spike when they switch on, and quite often it trips our MCB, our circuit breaker. Now, our electricity at home is enough to run these motors, but during starting we may have some problems that always the fuse is tripping, and this can be a little bit disturbing to people, apart from some other
inconvenience.
Yeah, some other inconvenience which are a bit very technical, but yeah, this is a little bit of a problem. So we want to have bigger motors and we can use them, but to switch them on, which we obviously have to do when we want to operate the motor, we may have a problem. And for this, there are special motor starting devices available, and one of these motor starting devices, or a very new technology, we developed at the University of Malta with an industrial partner together. So this is a nice collaboration project with a Maltese, with a local company that actually plans to manufacture these devices. So this is not just
is that called the high dynamic motor starter? Is that it or not?
Yeah. This is called this is the HDMS.
I told you I did some research.
Yeah, the high dynamic motor starter, because it's very dynamic. It means it can be used for many different applications. You don't really have to bother if it is an air conditioning compressor or large water pump. If you know you have a big motor, you have problems with the inrush current when you switch it on, you can just install this. This will dynamically adjust its performance to always start the motor smoothly without you bothering that the MCB may trip, for instance.
Okay, so ideally that is installed on every motor, of course.
Yes.
At home. And are you currently trying it out? What is the research? What is the phase of the research at the moment?
The phase is that MCST gave us some funding with the Fusion R&I project, which also gave us some funding to fuse industry and universities. So we have a nice collaboration where actually the product idea and the intention of manufacturing this product comes from the local industrial partner, and we at university, we had to improve it. So the first prototype was already available before this project started, and we just did some more investigations to make sure that it's really fit for the market, that the performance is satisfactory. So I had two master's projects, two master students working on this. One was investigating the performance of these very big transistors here, that they don't blow up, because when we have to handle the large current of the motor, we need to check that we really can take the current. And another student was working on the microcontroller control algorithm. Here's a small microcontroller where there's quite a bit of software to control the device, to control the switching. So this is quite a bit smart. Actually, it also has connection to a smartphone, so you even can go with your smartphone near it and look at some parameters and see some recordings of the device performance. So we worked quite a bit on improving the performance of these large power transistors and the microcontroller control algorithm.
Okay, so the main advantage is that that device makes sure that when you're starting off your washing machine, for example, or air conditioner or whatever, it starts off in a smooth way.
Yes.
In a way that it doesn't interrupt the actual flow of energy in your household. Yes, is that right?
This is correct. This is correct.
And also, it's also good that you can actually assess some diagnostics, I would assume, by your smartphone, so that you can actually check its performance.
Yeah.
One thing that I cannot help but notice is that it's quite big. As a
Yes.
where is that placed? Is it placed, for example, next to an air conditioner? Is it placed next in the before the air conditioner or within the air conditioner?
You could place this, for instance, in the outdoor unit of an air conditioner, where you have the big compressors, usually the outdoor unit, where you have the big fan. So you have a bit of a panel, and inside you have some space. It would go there next to the electronics. And yes, this is a bit big, but you can start motors that big, basically. So the motors would be at least 10 times bigger. So this is not the smallest product that is available for smaller motors. So this is already for up to 32 ampere motors, which are quite big motors.
I have a feeling that this is an area which doesn't really, is not the end of the story. It's rather perhaps the beginning of a story. I think there's a lot more research for you to do.
Yes, and we will see that the motors improve in their efficiency, and actually while the motors improve in their efficiency for their running condition, this makes actually the problem of starting a little bit worse. So when we use more higher efficient motors, this problem may amplify of the large inrush current. There is also a larger product which is also more expensive. This is the inverter. Then many air conditioning units also have already an inverter inside of washing machines, but they are then even bigger and more expensive. So this is a product that goes a little bit below the inverter. So when you have a product where you don't want to afford an inverter, because an inverter, let's say, costs 500 euro for the appliance, this would cost 200 euro, and just to start the motor, this product is good. So there's a not the hugest market in the world, but there's a niche market, and hopefully this will be in the future a successful business case for the Maltese local company which wants to manufacture and sell these products. So this is not just university research, this also goes now towards a product that we really gonna sell.
Yes, I think that's what makes it interesting, because like that, as a researcher, you'll get the opportunity to actually test.
Yes.
Test the market kind of in all of its different aspects. What about your research per se? It was divided, I assume, in the theoretical part and then in the practical part. So if I understand correctly, you're now in the second part, yes, in the theoretical part. What is the next step?
The next step is now a bit the ball bounced a bit back to the industrial partner, where they actually work a bit on the manufacturability of this product to bring all the manufacturing costs down. Like at university, worked more a bit on the circuit, how it technically works. So we made sure that the product performs very well, but it doesn't mean that actually everything is assemblable with a manufacturing with an assembly line. So at university we have more prototypes that we solder ourselves the circuits. Here we see already one version of the prototype which looks quite close to a practical product. The first prototypes we had at the university were more like wires running around, and the prototype was the size more of half a table. So
of course, so first you did the research from a theoretical point of view, then you built a prototype and saw that it worked, and it was like, now you're presenting it to the industry, for the industry to test it, further test it, and also see how what is the most practical way to build it, and perhaps also the most cost-effective, of course, solution for that. I think it's the whole process.
Yeah. It's a long process, and with this, R&I Fusion program that MCST published, it's a very good way how industry and university can help each other and find a synergy, basically, while the industrial partner has also the expertise now to make it manufacturable, to place this product on the market, while university has a lot of academic knowledge and nice research labs which could help a little bit in the theoretical investigating of the device performance.
In an interview you gave out, you used a comparison with someone working out at the gym to
Yes.
better explain I think it was a very good way of explaining what you have there. So could you, for the benefit of our audience, give us the same example, because I think we got what you guys are doing and what your research where your research is heading, but I think one would use this comparison that you brought already to better understand how that would benefit to have at home.
Okay, yes, like I said, we need to see how much these transistors, for instance, can take, how much current they can take to start a motor. And like when you go in the gym, you start with small weights, so we use low current, but eventually you want to get the maximum performance out of these transistors. So you try to go up with the current until you see eventually where is the limit. Then you see, the limit is still a little bit too low. We need to push a bit more. So you try to optimize the circuit, you try to optimize the control algorithm until you get basically the muscle power you need to start very big motors, because these days we also want that the product is very, very small, but the motors we can start are very, very big. So we had to train this a little bit, improve it with our research until we got a fit body, a fit product.
Okay, so you're a team of people, yes, working on this?
Yes.
Within the same faculty, I would assume?
Yes, yes.
And sorry.
Basically, I had 2 RSOs employed for this project, which were basically where the funding of the MCST Fusion project was used. These were 2 research officers. They also used this research work also to read for their master's degree. There we have Justin Schirup on the left and Daniel Lenny on the right and me in the middle. These are the 2 researchers which actually carried out most of the work. I'm a full-time lecturer at the university. Unfortunately, I didn't have the time to work full-time on this project, do all research myself, but I was guiding them and always looking at the results they get, and we were thinking like, what can we do to increase the performance? And then, Justin and Daniel went again back to the lab and tried the experiments until we got what we wanted. And it was hard work. The project has been going on for 2 years now, but we are quite happy with the results.
I would assume that you're happy with the results achieved so far, because this is, I would say, a very interesting concept to actually think about, let alone actually do, create.
Yes.
So you should be very proud of your achievements and that of your colleagues, of course, who worked on this project. And I wish you the best of luck with this and other projects you might have in mind. Do you have any other area you want to research?
Yes, actually, my latest area of research is quite a bit far off, I would say. It's about wireless charging of electric cars. And the idea is even further to charge these cars while you're driving on the road. So I work again with MCST and other industrial partners.
This is groundbreaking.
Yes, it is. But we now see that actually the biggest problem with electric cars is cost and range anxiety. They actually can't drive forever, and the batteries make the car very expensive. Once we manage to charge them on parking bays or even while we're driving on the road, we don't have to stop to charge the battery anymore because we are charging the car while we are driving. So we still would need the battery, but a smaller battery. It would bring the cost down. And also, if we are driving all the time on the road where we get energy, we don't have to stop anymore for charging stops.
And it might also make it accessible for people who do not own a garage.
Yes, exactly, because you're on the road.
And that is a game changer, I think.
Yeah, it could be something like you have some RFID identification. It means like text, basically when you drive on the road, your car would digitally talk a little bit to the charging lane, open your account in a Malta, because it will be charged obviously for the electricity consumed. Everything would go automatically, and every month you get a section in your energy bill, electric car charging, for instance, 100 units. Now, like I said, this is a bit far off because the technical difficulties are still great, and also cost-wise to for instance, install such large power converters on the roads would be a lot. But we all see it for mobile phones. We can buy these wireless charging pads. You just put on the phone, and it would work a bit in a similar way. It's just we are not talking about 5 watts to start to charge the phone. We talk about 20 to 50 kilowatts, which is a lot of power to transfer. But for me, this is a great research challenge too. There are still many things to improve, and I believe it will be there in 20, 30 years. When we think about 20, 30 years back, and someone would have said we have a smartphone in our pocket which has GPS, internet, everything. We have video, telephone, and all it's in this small phone. People would have laughed. The same when they may say, no, this wireless charging, it's a bit far off. But I believe in 20, 30 years we will be there because we need it. And me as engineer, I know we can do it. It is hard work. It will be a lot of work, but give us a bit of time. Yes, exciting, and this will be worldwide coming. Eventually, I think in 20, 30 years, we all drive with electric cars and we don't bother about charging. Everything will be done automatically. We get our bill at the end of the month, how much we consume. That's it.
Thank you very much for this interesting interview. I'm very glad that you came here and accepted our interview today. I wish you the very best of luck with your current research and also with the wireless car, electric car charging thing, which is very, very exciting as well. And I wish you the best of luck.
Okay, thank you for inviting me. I hope frequently I will come again and show some new results of new projects. Yes. Thank you for inviting me on Giornata Tajba.
You too, lilek ukoll.